Hi, my name is Isabel Dove. I'm a PhD candidate at the University of Rhode Island Graduate School of Oceanography. And today I'm going to be talking about evaluating diatom-bound nitrogen isotopes as a proxy for circumpolar deepwater intrusion on the Western Antarctic Peninsula. Before I begin, I want to give a shout out to my former lab mate, Dr. Colin Jones, who produced the nitrogen isotope measurements that I'm going to be presenting here. So why are we interested in the Western Antarctic Peninsula? This region is characterized by incredibly high primary productivity, so that makes it an important player in the Southern Ocean carbon system. This region is also experiencing rapid environmental change, so that we have modern evidence for both atmospheric and oceanic warming, reduced sea ice extent, ice sheet retreat, and circumpolar deepwater or CDW intrusion. While all of these factors affect the ecosystem and primary productivity, we're particularly interested in CDW because it is a relatively warm water mass that is nutrient rich, so it affects both the ice sheet and the primary productivity in this region. CDW is transported by the Antarctic Circumpolar current, and it can intrude onto the continental shelf. And the extent of this intrusion is thought to be controlled by westerly wind position. So if you have westerlies that are further south, that's going to be greater circumpolar deepwater intrusion. So in order to understand and project how circumpolar deepwater is going to respond in the future, we need to understand what it was doing in the past. So we can do this by looking at geochemical records preserved in sediment cores. So the sediment core we'll be looking at today is ODP Site 1098 on the Western Antarctic Peninsula, and it is in a location that is currently known to be affected by circumpolar deepwater. So again, our goal is to see if we can use the diatom-bound nitrogen isotope as a proxy for circumpolar deepwater intrusion. This is typically used as a proxy for nutrient utilization. The way this works is you start with a pool of nitrate with a known nitrogen isotopic composition. And then as nitrate is assimilated by primary producers like diatoms, it is incorporated into their biomass, and they will preferentially assimilate the lighter 14N. And there's this additional fractionation of the organic nitrogen into the diatom shells or frustules. And I want to note that this fractionation may be different depending on the diatom species you have present. So this is a complicating factor, but diatom-bound nitrogen isotopes are still the preferred proxy for nutrient utilization because their frustules protect organic nitrogen from alteration. So to summarize, as nutrient utilization increases, you see a corresponding increase in delta 15N values in both the remaining nitrate pool and in the diatom organic matter. You can basically think of the delta 15N value as a function of demand over supply. So thinking about circumpolar deepwater, which has high nutrients, that would be greater supply and thus lower delta 15N values. Looking at the data, so here I have a 2,000-year record from the mid-Holocene of diatom-bound nitrogen isotopes, which I am comparing to a published delta deuterium record, which is a proxy for westerly wind influence. So I inverted the axis here. So we have low values up top and higher values. We can see that these lower values coincide with less negative delta deuterium values. So again, low delta 15N values, that's indicative of enhanced nutrient supply. These less negative delta deuterium values are suggesting greater westerly influence. So this all lines up with more circumpolar deepwater influence on the Western Antarctic Peninsula. So I've highlighted two potential time periods of increased circumpolar deepwater influence. However, this correlation is not statistically significant, and we're only looking at a 2,000-year record. So this is just preliminary data, and we're not drawing any meaningful conclusions from this short record. So my future work is to extend the diatom-bound nitrogen isotope record throughout the entire Holocene and compare it to other published proxy records. And then, as I mentioned, the diatom-bound nitrogen isotopes may be influenced by different diatom species. So there's a type of diatom called a Catastris resting spore that is quite abundant in the Antarctic Peninsula. and its abundance varies quite a bit over time. So I will also correct my record for the varying influence of Catopsaurus resting spores over time. So lots of work ahead, but our preliminary results are exciting, and thank you.